Okay, so today we're diving into ketone bodies.
Yeah.
They're like this backup energy source that your body has.
Right.
We were inspired by this YouTube video called Metabolism Made Easy. Have you seen that one?
Oh, yeah, that's a good one.
Yeah, so we're going to kind of like follow along with their explanation of how ketone bodies are made and also where they are used in the body.
Okay.
I think it's super interesting because it kind of shows you how adaptable your body is when it comes to using different fuels.
Yeah, totally. It's really cool how the body can just like switch gears when one fuel source runs low.
Right. Exactly.
And ketone bodies are like a key part of that.
So let's start with like the basics. When we're fasting, what happens in the liver? Like it doesn't have its usual glucose coming in, right?
Right, so the liver has to adapt.
Yeah.
It basically turns to stored fat
Okay.
and starts breaking it down for energy.
Got it.
And that process is called beta-oxidation.
Beta-oxidation. Yeah, it's like dismantling these stored fuel reserves. Okay, so it's breaking down fat. And when it breaks down fat, what happens?
Well, you get this byproduct called acetyl-CoA.
Acetyl-CoA, right?
And it starts to accumulate in the liver.
Okay, so the liver's breaking down fat. We're getting acetyl-CoA. Now what?
So that's like the critical trigger.
Okay.
When the liver has enough energy for itself from the fat breakdown, all this extra acetyl-CoA starts building up.
Gotcha.
And instead of just wasting it, the liver turns it into something useful.
Okay.
Ketone bodies,
Oh, okay.
acetoacetate, and beta-hydroxybutyrate.
So it's like this excess acetyl-CoA gets converted into ketone bodies in the liver.
Exactly.
So the liver's like the factory.
The liver is the factory.
Got it.
It's the main production site for these ketones.
Okay, but they can't just stay there, right?
No, they can't.
They have to get out to the body somehow.
Exactly. And that's where it gets really interesting.
Okay.
See, acetyl-CoA itself, it's not easily transported out of the liver. But ketone bodies, they're different.
Okay.
They can dissolve in the bloodstream and travel to other tissues.
So they're like little energy couriers.
Exactly.
Going through your blood.
Yeah, so they're like a readily available energy source for other tissues.
So which tissues can actually use these ketone bodies?
Well, a bunch of important ones. The heart can use them.
Okay.
The brain can use them.
Oh, wow.
And even skeletal muscle can use them for energy.
Okay, so like pretty much everything.
Yeah, it's a really important alternative fuel source when glucose is scarce.
Especially when you're fasting, right?
Exactly.
So here's something that I thought was really interesting. They mentioned this in the Metabolism Made Easy video.
Yeah.
Even though the liver makes all these ketone bodies, it can't use them itself.
Right. Isn't that wild?
It's so weird.
It seems counterintuitive, but it's actually really clever.
Why is that?
Because the liver's main job in this whole process is to just produce the ketone bodies and then export them to the rest of the body.
Got it.